So in this video, we are continuing with the shifts of functions, and we are going to be combining horizontal and vertical shifts. And what we are going to do first is it says given f of x is equal to absolute value of x, sketch a graph of that transformation. So the first thing I'm going to do is graph the parent graph. Okay. And so this is our, let's say that this is f of x. Okay. And then we're going to do the transformation. So we can recognize that we should be able to recognize, hopefully, that there is a horizontal shift. And that is going to be found within that input inside the parentheses. So your input is inside the parentheses. And so that is going to indicate that we are moving left one. Remember that the idea behind anything having to do horizontal is taking the function back to x. So if my end result needs to be f of x and I have x plus 1, well, what do I need to add to this to make it go back to x? And so if you notice that we're having to add a negative 1, and so that left 1 is going to indicate that that would be a negative 1. And so what you would always want to do is on your parent identify some key points. Vertex is always a good one, and then something to the left and to the right. So we can take those table of values, which, let me clear this off. The table of values, let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we've got negative 6, 6. We've got 0, 0. And then it looks like we also have 6, 6. All right, so that's going to be our parent. Now, if I'm shifting it to the left one, then that would make my new x value, I would be subtracting 1 from each one of those. And that's going to give me a negative 7, a negative 1, and then a 5. And then now we can look at the vertical shift. I don't want to do purple. Let me do a different color here. All right, so let me do a vertical shift here. And hopefully you guys can see that that vertical shift is on that outside, and it's going to represent down 3. So what we're doing is subtracting 3 to the y values. So 6 minus 3 is going to give us 3, then we're going to get negative 3, and then we're going to get 3. All right, so then these are the new points that I would have, and then I would go ahead and graph those. So I'm going to have negative 7 and 3. I'm going to have negative 1, negative 3, right? Because I'm going to the left and down. Again, I'm going to the left and down, and then I should be able to connect those. And there you have that graphical transformation. All right, so now we're supposed to write a formula or an equation for the graph shown at the middle right. So I'm going to give you the graph right now. That graph is going to be at the location of 1, 2. I'm sorry. It needs to be 1, 2. It's going to be 2, 3, and then it's going to be 5, 4. Okay, so there's the graph, okay? So it says write an equation for the graph shown at the middle right. This is a transformation of the square root function. All right, so let's take a look. We always want to be able to graph the parent, know some of those characteristics. And this would be rad x. So the parent is going to be y equals rad x. And let me just give you the quick set of xy chart for that parent. So we've got 0, 0, 1, 1, and 4, 2, right? So if we were to plug in 4, the square root of 4 is going to give us 2. So now what we can do is we're working backwards. We want to be able to look at this and create the ordered pair and then analyze the x's and the y's. So this first ordered pair is 1, 2. The next ordered pair is 2 and then 3. And then the next ordered pair is 5 and then 4. So the idea behind this is that we want to be able to see how the x changes. So I'll write down, how does the x change? And then how does the y change? And so hopefully you are able to see that the x goes from 0 to 1, from 1 to 2, and from 4 to 5. So it looks like it went to the right 1 unit. And so that would be an indication that it is going to be inside the parentheses because we're dealing with the x. And if I wanted it to be right 1 unit, then I would have to have x minus 1. Remember that you're trying to take it back to x, and to go right 1 unit, we would be adding 1. All right, so that's going to be the horizontal change. And then now let's take a look at the vertical change. So we are going from 0 to 2, from 1 to 3, and from 2 to 4. Now remember, this change has to be consistent along the entire set of y values. So if somebody were to say, oh, look, they multiplied by 2. Well, they only multiplied by 2 on the last one, because 2 times 2 would give me 4. But if I were to multiply this by 2, the 0 by 2, that would give me 0. And it's not 0, I actually have a 2. So I am thinking that what we're doing is we are adding 2. And remember, it has to be consistent. And so if the y changes by adding 2, then what we would do, remember that this is going to be the graph of f of x. Let's make the notation, let's call this g of x. So that means the equation g of x is going to be the square root of x minus 1 and then plus 2